Okay, so what I want to show you guys here is in chapter 5 on page 76. The author lays out a fraud training set where he explains k-means clustering and does some calculations by hand. And so for the first part of assignment 5, I want you guys to replicate this, so hopefully it will help you understand how the math works. So what we have is we have a series of 10 cases, and the author has scored the ages and the claims and the ticket score, number of tickets that drivers have received, and whether or not they've had prior claims, and whether or not they had an attorney using some algorithms to convert ages such as 50 or 30 into a variable between 0 and 1. So over here you can see I just sort of reverse engineered using the formula that he describes in the book to give you an idea of what the ages might be that are represented by this score from 0 to 1. Then gender is just 0 represents female and 1 represents a male. It's just a binary value representing either or. And then claim score is based on, a max value of 1 minus a claim divided by 5,000 basically. And then a score based on tickets. If you have 1 ticket, then or 0 tickets, it's a 1 ticket is 0.6, and 2 or more tickets is a 0. And then ultimately, and then same thing for prior score and attorney score. You guys can look at it, and we'll also see in the R code how these things are calculated. So in k-means, what we're doing is we're basically squaring the difference between a value, and in this case we're going to look at case 2, and a center, which is really just means the average of a number of values that are represented by a particular cluster. So in the example they show in the book, they just select record number 1 as representative of cluster 1 and record number 3 as representative of cluster 2. And so you can see here I've done the sum of squares where I've just gone through and squared each one of these values to produce this sum. What we do when we calculate the cluster distance is we go through and we subtract the averages for the case that we're comparing it to and the cluster mean, which in this case is just the values from case number 1. So here we've done the difference and we've squared it, and we go through and we do that for each one of these columns to produce a value which is ultimately reflective of the distance in a Euclidean sense, a squared plus b squared equals c squared, from the either cluster 1 or cluster 2. So we've calculated these two distances, and then whatever cluster we're closest to is the assignment then that our value receives, right? So we can see that we are closer to case number 1 or cluster 1 than we are to cluster number 2. So our case number 2 would receive the assignment of cluster 1. And so normally what's done in k-means is the algorithm will go through and keep moving the centers or the average of all the members of a cluster around until it minimizes the distance between the members of a cluster and the center, right? So it's really just reflective of coming up with a group that is as similar as possible to itself, I guess you would say. So all right, what we end up doing is in this table down here, we create the distances for all of our cases and then assign them to a particular cluster. So obviously cluster case one is going to be closest to itself, so it gets assigned to cluster one. The calculation we just did for case number two, the assignment ends up being cluster number one. And then you can see as we go down through here, we do a cluster assignment depending on which of these distance is the least. And then we can see that, you know, based on this cluster assignment, hey, you know, originally we picked a case where there wasn't fraud and then there was fraud. And when we say, you know, based on this, you know, are we being kind of predictive of fraud? And then you can see, you know, how often we're right here on this column. Okay, but after that, what we do is we recalculate our centers based on the average of the cluster assignments. So you could see here, I've gone through and averaged up everything that is assigned to cluster one. And on this bottom one, we are averaging everything that is assigned to cluster two. And the averages of these are what we would use for the second run, if you will, through the algorithm. And we'd recompare all of the values to these averages and then do the cluster assignments again. So hopefully working through this by hand will help you to kind of understand what's going on with clustering, with k-means clustering. And so I've given you some screenshots of the formulas that I'm using inside of Excel. And what I want you to do for your assignment is just go ahead and recreate the results from page 75 of the book using Excel. And then ultimately what we'll be doing is we'll be doing this inside of R as well. So the only part of this that you need to do is this part. I want you to take these cases up here, and I want you to, you know, calculate, you know, how case two is assigned here, as I did with sort of the long form showing the differences in squares for each one of these, and then create a table that shows all these values, various calculations. And I want you to actually have the math in the spreadsheet that you submit, so that I know you have a pretty good understanding of what we're doing here. Now, after we do that, we're going to go ahead and jump over into R, and we are going to recreate what we've done inside of R here. So I'm going to go ahead and clean up everything I've got here, and then walk you guys through how to recreate the example that we saw in the book and recreate it in our spreadsheet inside of R and RStudio.
Over here on the bottom left, you know, we can see our environment variables, and on the bottom right here, we've got where we can see the plots or graphs we create and help menu and that type of stuff. So, okay, first thing I'm going to do, I'm going to set my my variable. It just says, hey, this is my computer. Then I'm going to set my working directory. So I've given you guys this script. If you set your working directory, clearly it is not going to be the working directory that that I'm using on my machine. What's going to be important for you here is there is a data set attached to assignment 5 called fraud.csv that you're going to want to put in your working directory so you can get at it. So all right, I'm going to set my working directory. This just tells R that, hey, this is where we're working, and when I say look for stuff, this is the place to look. And so the next thing that we want to do is we actually want to recreate that training set. So that training set, if you remember, we go back and look, was just a bunch of, you know, these variables put together for our various cases. And in R, I'm actually putting them in a vector, sort of going down the column here. So you see here, I've got this age score, 1.9, so on and so forth. If we flip back to RStudio, you can see I've just first created a case ID. This is really the case number. And then you can see I've got my 10 values for age score, and then the values out of all my subsequent columns. And we're going to stick these into variables and use these to create a data frame inside of R that we can then apply k-means and other functions. Now, the other thing you'll see that I have here is I actually have a couple of functions that I'm creating. So this PCH color we're going to use for plotting, and the purpose of this is just to pick the color of the symbols that we're going to be putting into a scatter plot. And then I've got this PCH symbol, and just again, this is a function that we're going to use to pick the symbol that we use in our scatter plot. So one of these is a diamond and the other is a square. And if you're like, where did you get this stuff? How did you know about all this type of thing? If you go out and were to just look on the internet, say for instance we jumped onto Google here and I typed in R PCH symbol and hit enter, you'd see that we'd end up with, there's a million different places where you can find that people put these little cheat sheets together that allow us to kind of know what these codes represent. You might also be able to find this in some of the R help as well, but I've found that the internet is quite a bit more handy than the documentation at time in helping you figure these things out. So you can see here I had the PCH value of 17. That's this triangle right here, and the PCH value of 18, and that's the diamond value we see right there. And then I have another thing for sizing these symbols here, and this is just a little thing I did to make these things kind of appear to be the right size on our graph when we produce them. And then the last thing I have is this little PCH label function where I'm just doing a transform on that outcome value that says, hey, if it's a 0, let's make it okay, and if it's a 1, then let's go ahead and make it fraud. So okay. These things are, I don't really expect you to deeply understand this, but I want you to know what I'm up to, and hopefully, using these will give you a little more practice than use in R. So, okay, I'm just going to highlight all these and hit Control Enter to execute that, and then we can see over here on our bottom left that we've then populated all of these variables with the values that we had with our combiner thing. And then you can see we've created these 4 functions over here too. And I think if we were to click on this, we could actually see the definition of one of these functions, right? And so that one's pretty simple. That one's pretty simple. They're all pretty simple, but there's the functions that we created. Now we want to actually use these vectors we've created to create our fraud training data frame. So you can see here I've got this fraud training data frame or variable that I am going to assign this data frame that I'm creating to. And so what I've done is I've just typed data.frame, open close paren, and I'm taking each one of these vectors and using them as an input to this function. So if we execute this, we can see that we have created our fraud training data set. If we were to expand this thing out over here, we could actually see the values, right? We now know that we have actually inserted those values into it. And then if we were to just highlight fraud training and say, hey, let me see this thing, now we can see exactly what our data set looks like over here. And now this really pretty much looks exactly like our spreadsheet was looking. We've got all these same values in here. And what we want to be able to do is to say, okay, I think I understand the math, and now I'm in R. I want to see if I can come up with the same results as I got out of my spreadsheet. So if we wanted to do that, there's a couple things we need to do. So first thing is we'd have to, I think the default iterations, the number of times that k-means is going to recalculate the centers, I think is set to 10 by default for k-means. And you can see down here is the built-in function for k-means. That's the part of the base R. And we're going to actually set our iteration to 1, which says, hey, I only want you to use the center, calculate the cluster averages once. And by the way, I'm going to tell you, rather than randomly picking a center, I want you to take the centers that I defined for the first iteration you're going to do. And so we define these centers right here. You can see I've got a variable called cluster center, and I'm going to populate it with some values out of our fraud training data frame. And you say, well, what are those squirrely numbers you got there? If you remember how data frames go, we have basically we can refer to the entire data frame like this by, like I did before, just executing on its name, or we can pick out a particular value from the fraud training by kind of using this array syntax. And the way this works is the first value that we put in is going to be the rows, and the second value is going to be the columns. And you can see I'm using this combiner function. So if you guys have completed your R basic training that I gave you, remember this combiner function is the way that we pass multiple values into the spot where R kind of expects one value. And here I've got 1, 3, which means give me row 1 and row 3. And then for the columns, I've got my combiner function, and I've got 2:7. And what that means is give me all of the columns between 2 and 7. So if I were to just execute this and not assign it to my center, you'd see, hey, there's row 1 and row 3. And if we remember, popping back to our spreadsheet here, hey, here's row 1 and row 3. These were our initial cluster assignments we used to calculate these distances down here and figure out which cluster we should assign case number 2 to. So, all right, I'm going to go ahead and assign those to our cluster center variable. And then if I were to just check that cluster center variable out, you can see it is representative of the 2 rows out of our fraud training set that we want to use for our centers. And then in our k-means algorithm down here, I am explicitly say, hey, your centers is going to be this cluster center. And I've told it in this case to use columns 1 through 6 because the 7th column is, well, it's columns 1 through 6 because up here we assigned, in creating cluster center, we use columns 2 through 7, right? So if you think about just shifting over one, this thing has 6 columns in it. 1, 2, 3, 4, 5, 6. So I could just as easily tell this thing, not put anything in here and just say, hey, use all of it, and it would. So 6 one, half dozen the other. Okay, so what I am telling it here is here's the data set I want you to use, fraud training 2 through 7, and that's just so For the k-means algorithm, we do not want it to use our ID values, which identify our rows, because they don't have any meaning. So when calculating distance, the ID is not a part of that calculation. And then we want it to use up through our attorney score, but we don't want it to use our outcome. And then we've set our centers here that we're telling it to use for its initial calculations. We've said, hey, only do this calculation once, and in order for this thing to be happy, there's several different types of, several different algorithms we could use for k-means. In order for this example to work, we just happen to use it for use this Lloyd one. You can say, hey, Arthur, where'd you get that from? How'd you know that? Well, if you remember how to use the help menu, if I type in question mark k-means, and I were to execute that, you'd see down here we get our help stuff, and it would tell us basically lots of stuff about this k-means algorithm that we're going to use. And from an algorithm perspective, you can see right here it shows us these are all the different choices we have as far as the algorithm to use. I'm not going to pretend to be able to explain to you the intricate differences between these, but there is a difference, right, in the way that it does its calculation. And then here we can see the arguments that we're using. We're using X as just the data set that we're passing in. Centers is optional, but we're setting it iteration max, the maximum number of iterations to be allowed. Here, if we're randomly choosing our centers, how many, what's the number of values we should use for our initial calculation. There's the algorithm, and then there's a couple of other values here that you can read about, and then it essentially goes through here and will generally explain to you a little bit, generally a very little bit, about the values for this particular algorithm, give you some references, and usually you'll find an example too that gives you an idea of how to use this stuff. And R comes with a whole bunch of built-in data sets, or in this case, they're just doing a calculation to randomly generate some values. But normally the examples they give you, it's not like you have to go out and find the data set. They'll provide it for you, and it's part of your base R explanation or installation. And I find those examples a lot of times to be really handy because it can be kind of hard to understand this stuff just reading it. But if you use the example, it makes it quite a bit easier to take the example, play with it a little bit, get your bearings around you for how to use something, and then then you can apply your own data at that point. All right, I'm going to go ahead and move my desk down here a little bit. All right, so now what we want to do is we actually want to run the k-means algorithm with our inputs, and then we want to assign the results to this variable called fraud cluster. So if I run fraud cluster right now, you can see, hey, it's not there, and then if I run this, and we will have assigned the results of our k-means to this variable. And you can see, hey, this didn't converge in one iteration. What that basically is saying is, hey, you didn't let me go through this enough time to find the best center, right? But that's okay by us because we're really just trying to figure out if we can reproduce our results. So now I'm just going to execute that fraud cluster, and you can see here that it kind of barfs out all this information that was calculated, right? So here we can see these cluster means, and if we went back to our spreadsheet, we would see that those correspond exactly with what we came up with in our spreadsheet. And then we can also see um, the clustering assignments here. So we could see, if you think about case 1 through 10, 1, 1, 2, 2, 2, 1, 1, 2, 2, 1. And hopefully if we go back to our spreadsheet, 1, 1, 2, 2, 2, 1, 1, 2, 2, 1. We've gotten the same assignments out of our algorithm that we got from our spreadsheet. And then here, it's got some other information about the sum of squares and that type of stuff. And then you see you have all these individual attributes of this that can be referenced independent, right? So what are you talking about out there? So if I say fraud cluster, if I were to just copy paste this thing here, I hit $, you see it'll pop me up these values that you see here. So if, for instance, I wanted to see just the cluster assignments, then I would see the cluster assignments. And you say, well, that's kind of, I don't really understand what that means. Basically, these are in order of the data set that you fed into it. You'll see in a few minutes that we can actually join this back to our data set and kind of materialize those cluster assignments within our originating, within our original data frame. So, okay. You can see, hey, we looked at our the results of our clustering. It matched with the calculations that we did by hand inside of our fraud, or inside of our spreadsheet. We, reminded ourselves that, hey, anytime we need help on something, you just put a question mark in front of it and get some documentation on it. And now we want to see of like, hey, what can we do to actually kind of represent the results that we just produced? So if we take a look here, you could see, if we just look at our fraud training data frame, remind ourselves of the columns we have available to us in here, we can actually plot these against each other and with the cluster assignment to see if we can get any hint from the clustering assignments that one variable might be affecting the other, or we can see some sort of correlation between stuff. So here I'm using a command just called plot, and this is a generic function in your base packaging, and there's a number of different types of graphs that you can draw with this. And I'm saying, hey, I'm going to pass in the values from fraud training, and you can see for my row position, I haven't put anything, which translates to all. And then I'm also saying, hey, take values 2 through 5, which is essentially everything between the age score and the attorney score for the columns. Then I'm using the cluster assignment. I'm assigning to col, which stands for color, which just says, hey, use the cluster assignment to determine the color that you're going to associate with whatever it is you're going to plot for me. And then we're also going to use a separate function here to represent our centers on our graph as well. So okay, let's see what's actually going on here, right? So I'm going to run this plot thing, and you can see down here now, it actually created a visual representation of our results. So we have our ticket score on the left-hand side, and then we have our age score on the right-hand side. And so I've got, I'm sorry, I said column 2 through 5. I meant column 2 and 5. If we were to look at our columns, you can see we have age score, and then 3, 4, 5 is ticket score, and it was XY, right? So we've plotted the age score on the bottom and the ticket score on the Y-axis. And then you can see, hopefully it comes through here, that red is representative of one of our clusters, and then I want to say it's black is the representation of our other cluster. And now the other thing we can do is we can actually render the cluster centers, right, the kind of means, if you will, onto this graph as well to see, give us, some sense for how close the members to a particular cluster are to it, right? And so when we look at this, we're saying, well, these over here kind of seem close to the center, but then this red one is right up next to it. And this is where, a two-dimensional representation of a cluster becomes a little hard to understand, right? If you think about it, we are calculating the distance, the Euclidean distance between 1, 2, 3, 4, 5, 6 dimensional attributes. But it's not possible for us to think in 6-dimensional space, right? So really, anytime we get beyond 3 dimensions, it sometimes these things can be a little hard to imagine. But in any case, we keep trying with this, and hopefully, we can find that sort of right combination of variables that begins us to give a hint towards what we might do with further exploration. So now, okay, hey, what if I just fed the whole data set into this plot? That might be interesting, right? Let's give that a try. Now what you can see is actually creates this scatter plot for every variable against every other variable in here. And so you can see as it just goes down through diagonally and produces these scatter plots, plotting, in this case you have the ID and the age score, and then the ID and the gender, and so on and so forth. And then you can figure it out just going across here. We're plotting each one of these variables together, trying to look for really a pattern in the clustering. If we see stuff that's kind of grouped up close together, then we start to feel like we might be discovering a pattern. And then we could also put the centers on here. They won't really represent in this particular case, but just be aware that you can. There's a number of different ways that you can crank out various plots. We're going to do a bunch more of this as we move along here. So, okay, I mentioned to you that, hey, we can actually take this cluster assignments and put them back into our data set. So here I've just got the cluster assignments that came out of our fraud cluster. And then here I've got the fraud training data set. We can see right now that it doesn't have a column called cluster. What we're saying is, hey, create this column in our data frame that represents the cluster assignment. So I'm going to go ahead and do that. And now when we do that, you can see that we have our cluster in our data set. Maybe if I just pull this over a little bit more, and we'll run this one more time to show you. There you go. We have our cluster assignments for each case now back into our data frame. And why this is handy is, hey, you may be wanting to track these clusters over time, cluster assignments over time. So this would be one way you could do that. Or you may be running multiple clustering operations and want to sort of compare the clustering assignments. And so you might have cluster 1, 2, 3, 4, 5. It's columns here, and you could keep all of those cluster assignments in your data frame, and then ultimately you can write this back out to a file source if you wanted to. And I'll show you how to do that in a second. So when we're using our base graphics here, this par command is it's pretty interesting, right? Because this really describes a lot of the variables that are used as the graphical parameters. So I've just invoked the help menu for par, or the query graphical parameters. And if you look down through here, you can see there are a number of variables that are used in the creation of various visualizations that you can create out of par. So, one of our big purposes in life is to be able to render visualizations based on the um, operations that you're doing inside of it. And if you just scroll down through here, you can see that there's all sorts of stuff we can do, from color assignments and the labels and various other things, font manipulation, the value, whether our text is rotated one way or another. I mean, there's all sorts of stuff that we can do here. So one of the great things about R is that it is almost infinitely configurable. One of the painful things about learning R is that it is almost infinitely configurable. So your base graphics are pretty powerful, but the learning curve is kind of steep on this stuff. You really got to mess with it for a little while to get the hang of it. And then there's a number of other packages such as ggplot and stuff of that nature that is even more powerful and potentially even more painful as you go along. And I don't know what to say about that other than to say that if you're truly interested in this kind of stuff, you're going to be kind of forced to dig into it. Now, the beautiful part is, the interweb exists, and you will find an unending pile of examples and Stack Overflow and all these other things that are out there to help you with this stuff. And there's all sorts of free tutorials, or even moderately priced online classes if you want to go super deep in Data Camp or Coursera or those type of things that will show you all the deep, dark knowledge you need to have about R. But I would say that you can probably learn just about anything you want to learn for nothing, if as long as you're sort of masochistic enough to do it. So here we're going to do some more plotting operations, and I want to give you a sense of some of the others, of kind of the power of what you could do. We had just an auto magically generated chart. Now we're going to actually play with some of these variables. So you see this command dev off. R has the capacity to render these things on multiple devices. That's like, what are you talking about now? So if you look, if I were to run one of these plots again, you can see that, hey, I can export this thing and I can save it as an image or as a PDF or copy it to my clipboard. So you can write these to multiple places, and essentially there's different drivers involved when you do that. When you say dev off, you're essentially saying, hey, clean up everything I've done and I'd like to start over. And that's pretty handy because this PAR, your graphical commands, has a set of sort of default values. And as soon as you start messing with them, that can kind of get in the way if you are wanting to do something else that is kind of reliant on some values being set to their defaults. Run this dev off. It's basically the reset button for that stuff, and you can sort of continuously mess around with your graphical parameters. By the way, if we want to save this thing off as an image, we can just do that, and this will be part of what you need to do to complete the assignment. There's a number of screen prints I want you to prove, or a number of screenshots I want you to put in the document you're going to submit for this. This is the way to do it. You say, hey, save this as an image. You can pick a directory, and then when you click that, you will have a PNG file exactly of whatever thing that you've created. And then you can mess around with the width and height of this. And this is all handy because if you wanted to put together a document of visualizations, you created it in R so that you could give somebody an explanation of some wonderful thing you found from your data analysis. this really gives you the capacity to have a lot of control over the size of those and tweak things to be used in your final product. So you can also save these off as a PDF using sort of all the same commands that you're used to using. So if we were to preview that, it would pop me up a PDF document of this plot as well. So there's just a number of different options for cranking these things out, and you'll be using some of those as a part of completing your assignment here. So now, what am I going to do? I'm going to run this dev off command to just make sure I've cleaned up everything. You'll see that gets rid of the plot that I had. And now I'm going to set some of these parameters for creating my visualization. So this XPD equals true, what that means, is just essentially setting the behavior of how certain rendering operations will have. And what this really means is, hey, if I want to put an independent label or an independent legend on top of my graph, I want you to make it so I can kind of write it over white space without it being obscured or anything. We'll see kind of how this works in a minute here. And then this margin is really just a matter of defining the outside margins for a particular drawing. So I believe this goes left, bottom, top, right, or maybe I got that messed up. I've got it down here a little further. But this is just defining the number of lines of text that we're going to leave open when we render a visualization, so that we might want to put other things in there, for instance, such as a legend. So here you can see that I've got this plot thing, and then I've actually put a number of variables in, so I can do some of this stuff iteratively. So you can see I've got my fraud training data set, and then here for my columns, I've got an X and a Y, which I'm basically saying, oh, this is what I want to put on my X-axis, and this is what I want to put on my Y-axis. And then I'm just defining those up here. So I'm just, this allows me to go through and set the values for the columns I want to use in my plot. And then here you can see again, we're going to set our color, this time using our function that we created way up above, and we're going to pass our cluster assignment in, and this function will pass back the color value we want to use for our cluster assignment. Then I am saying I would like to give my visualization a title, and we'll call this K-means results. I don't want to draw a box around my plot, so this just takes that box out. And then I've got a couple of things commented out here, just so in case we wanted to use them. This AXT equals N would allow me to shut off the production of the X-axis. The Y shuts off the Y-axis. I can define things like how many, what the value, the limits for the X and Y axis are, and how those axes behave when they're rendered as well. Next, I'm setting the PCH, which is the symbol I want to use in my plot. We're using this function that we created above, where we're basically going to assign a shape to use in our graph based on the outcome from fraud training. So we're just saying, hey, we'd like to use a certain symbol for fraud and a certain symbol for OK. We are setting the size of how our symbols render relative to the rest of the drawing using, again, this function that we created above. And I just use this because the diamond and the square don't render quite the same size, so I use this function to tweak the size so they appear to be the same size. And then ultimately, we have this YLab, which stands for the label for the Y-axis, and the label for the X-axis. And all we're going to do here is using our column names function, that is a default function. We're going to say, hey, get the column that corresponds with Y and the column that corresponds with X, and use those as the labels for our plot. So, okay, I'm going to go ahead and set the values of X and Y. Then I'm going to go ahead and run our plot function, and let's see what happens. So you can see that, hey, we've called for column 2 and column 4 out of our data set. Column 2 is the age score. Column 4 is the claim score. It renders X then Y. So our age score is plotted on the X-axis. Our claim score is plotted on the Y-axis. And then for each of our cases, we can see that that the green represents one cluster, the red represents another cluster, and then we're using triangles and diamonds here to represent whether a case represents being fraudulent or not fraudulent. Now, one of the things you can see that's missing here is like, okay, it'd be nice if we had a legend or something that gives us a little more information about that, and I'll show you how to do that here in just a second. So, and then last, you can see we've got this title for obtaining these results. So now if I wanted to plot a different column against this, I could just change that Y value. I'll just rerun the whole mess again, and we can see automatic label turns to ticket score, and then we should see that these things sort of shift around a little bit. And sometimes the comparison between those is pretty interesting as well. So we have a case where we might want to get multiple graphs onto our screen at one time, and there's a mechanism for doing that I'm going to show you too. All right, so let's move down here and try a little more complex example. I'm just going to clear everything out here. I'm going to set my graphical parameters, giving myself some extra space on the right-hand side. I've got my X and Y assignments again, and I'm just going to set those variables. And then here you can see that we've got, essentially this same function or same values that we're using above with a couple more things placed in here. So in particular, I'm shutting the Y and X axis off. So I'm going to put those in there post the rendering of my plot. And then, the rest of this is pretty much the same, except I'm also saying, hey, don't just automatically put my X and Y labels in. I want to manipulate those myself. So, all right, I'm going to run this. You can see, hey, we created a plot, but, geez, all I see is points, right? That seems kind of squirrely, but that's by design. What we basically said is go ahead and render the points. We're going to do, and then we'll do the rest, right? So the first thing I want to do is, hey, based on the value that I'm pushing in here, some of my values out of our data set are binary, 0 or 1, and some are kind of scaled from 0 to 1 with increments of 0.1. So I basically created these functions, or an if-else statement here that basically just says, hey, if the total number of values for me to plot is greater than 2, then I know I basically want to use a scale that is a sequence of numbers between 0 and 1 on 0.1 increments. And if it's not greater than 2, then I'm pretty sure it's just binary, and I just want you to use 0 and 1. And we're going to assign these vectors and numbers to an X and a Y group so that we can use those in the creation of our axes. So I'm going to go ahead and just execute both of those. And you'll see over here you get these zeros because we're just, the output of this is not reflective of our assignment to this. If we look at our X-ats, we see that it has 0 and a 1 in it. If we look at our y, we can see that it's got a scale from 0 to 1. All right, and this is based off of these column assignments up here. So if we were to scroll way up again and take a look, we'd see X, which we're going to rendering as third, right? That's this gender column. It's binary, 0 and 1, and then 2 is the H score. That is a continuous variable between 0 and 1. So, all right, we have come down here and calculated the scale of our axis labels. And now we actually want to create an axis, right? So I'm going to render an x-axis, and I'm basically going to say, hey, create an axis. It's on side 1. 1 is the bottom, 2 is the left, I think 3 is the top, and 4 is the right. So you can put these basically wherever you want to. And then the position of my values is going to be this, the values that are in this variable that we just assigned the values to. And then the labels are just going to be the same thing. And I have this tick mark, which is just reflective of the little tick marks that we're going to draw on our axis. So let me go ahead and execute that. And you can see now, hey, this drew the x-axis. We have a binary variable, so it goes from 0 to 1. And these, you can see there's the little tick marks showing that, which shows that we wanted them to go down because we had a negative number up here. If we wanted them to go up, it would just be a positive number. All right, so now we can do our y-axis. Put that on there, and that renders our y-axis. And we know that normally these numbers would come out as 0.9, 0.8. That kind of looks ugly. So right here, I just put this little function in to strip the zeros out. And I'm just basically saying, hey, wherever you see a 0 and a period, just substitute a period for it, for this set of y values that we have. You can see here, this LAS2, I'm rotating the text. So this just rotates it so it displays in this vertical fashion. Otherwise, it would be, all the numbers would be turned on their side. Now I want to create a title, or I want to label my y-axis. Basically, again, I'm just using the column names, using this title function, and then this MGP just gives me the capacity to affect where this particular title gets rendered. So I have the capacity to essentially render this thing anywhere on the screen that I want to through the manipulation of this vector right here. So I'm going to go ahead and execute that. You can see that puts our H score over here. And then if I do the same thing for our X, you'll see it puts our gender label on the bottom. And we have created our axes and our axes labels completely independent of the values that we've plotted. Now the other thing we can do is we can actually create a legend. So here I'm going to say, hey, I need to give it an X and a Y position. You can see, well, wait, you're using, what's that par user thing? Whenever you render a graph, it basically stores the corners of the space that graph occupies. If I were to just execute that, you'd see over here that it has this space for the x1, x2, y1, y2 parameters, sort of relative to this space. And we can use these to position things by basically saying, hey, we want to get to one edge or the other based on the value that's in this, what is essentially an array, right? So I'm picking this second value and this fourth value for my X and Y representation of where I would like to put this legend. I'm saying don't draw a box around the legend. Don't worry about the XPD setting. And then here's the labels I'd like you to use in our legend. I'd like you to render a line that is of a width 2, a line type of 1, which is the one of those things that you can look up on the internet or look into help. Its size relative to the rest of the graph, I just like to set at this point 8 value, and then I'd like to use color assignments 3 and 4 to color those lines. So that's a lot to digest. Let's just look at what happens when we actually render the thing. It puts cluster 1 and cluster 2 over here, and it shows that cluster 1 is green and cluster 1 is red, right? And we use the line because we don't want to confuse anybody about what this means. So we basically want them to associate, okay, it's the color that shows the cluster assignment. And then the second thing is, hey, we want to put the symbols on here and give a label for these, right? So it's the same thing we just did. You could see that I'm adding a little bit and subtracting a little bit from the X and the Y respectively so that I don't render the second legend on top of the other one. No box, same XPD. Here we are actually inserting a label for our symbols and the symbols themselves in our legend. We have our relative size and our symbol size as well here. So let's see what we get when we execute this. Now we've shown that, hey, the triangles are representative of cases that did not result in fraud, and the diamonds are representative of the cases that did. So now this gives us a sense from a cluster assignment of, okay, obviously, our cluster isn't indicative of fraud or not because it's getting a little bit of both in them. But here, it just shows that we have this sort of fine-grained control over the renderings that we can produce inside of R, right? And so if I came up here and wanted to pick different values, because we've variabilized everything here, we could do, say, column 4 and 5 instead. Just change these variables to 4 and 5, and everything should just sort of auto-magically adjust for us. So now I'll just run this whole mess one more time. Now you can see we've got our claim score and our ticket score, and our legends still showed up where they're supposed to. And now we can see, how these values cluster relative to these two measures. And that's kind of what we're looking for. We're looking for patterns in the data, and then this is one of the ways that you can do it. So now, and this part is important because this really digs into our, one of the things we need to do in our assignment is, hey, let's render a series of plots together, right? And you say, well, how do you do that? There's another one of these graphical parameters, and that's this MF row, right? So you can see we've got this set to 2 and 3, and that essentially says that, hey, I would like 2 rows and 3 columns with which I can put stuff into. And then I would like an outside margin around the whole mess that is that has these values, and you see bottom left, top right. So I want a bottom margin of 4 lines, a left margin of 10 lines, and then 1 and 1 for the top and the right. And then the margin parameter actually applies to the individual plots that we'll be putting in our grid here. So we're just saying, hey, put these margins around the individual plots, and then we want to be able to make sure we can write stuff on the edges and stuff and have it show up essentially. So okay, I'll execute these 2 things, which clears everything out and resets our graphical parameters. And now you can see, hey, you've got a for loop there. So if you're familiar with programming, say, hey, I'm obviously going to do something a number of times. What I'm essentially saying is, hey, for I in combiner function 1 through 6, which you can read is create a loop that I iterate through 6 times. I would like to use one value for x, so I'm going to compare everything using one x value, and then I would like you to iterate through the other values for the y-axis, right? And so for fraud training, we're going to use x and y. So this should basically create us a bunch of different plots with one value on the x-axis and varying values on the y-axis. So if we scroll up again, we take a look, we should be rendering the H score as our x-axis, and then all the rest of these in a series of plots on our y-axis. So our color is again being driven by our fraud cluster using the function that we created. We're going to put a box around it. We're going to draw the x and y axes ourselves. We are going to use symbols based on the function that we wrote above. We're going to size those symbols based on a function, and then we'll create the x and y labels ourselves as well. Again, we are going to determine the scale of our axes using this if else to make sure that our axes are variable as well. And then we're only going to render the x-axes in certain situations. So we're going to have a group of plots that we essentially only want to put the x-axis labels and on the very bottom of our series. Then our y labels are going to be applied to all of our plots, and then ultimately we're going to put our y-axis label on all of our plots as well. And then this is the end of our for loop right there. So you can see, hey, we're going to iteratively go through and render a bunch of plots. That's the gist of what's going on here. First, we set up the space that we're going to do it in, and then we do it. So, okay, let's go ahead and just execute this thing, see what happens. So now you can see that we cranked out 6 different plots, and we put the X labels on them. We've got all of our points in. We only put the X axes on the bottom because we feel like they translate up and they're all the same thing, so there's no need to render them a bunch of times. We left ourselves a bunch of space on the left-hand side to draw some other stuff, and a little bit of space on the bottom to draw some other stuff. So now, if I come down here, I can draw that other stuff by putting a legend in. So first thing, I'll put my cluster 1 and 2 assignment. You could see I could probably stand to, jigger that over a little bit. These X, Y values right here is how we move it around. So if you get to playing with stuff like that, you can do it. But I'm not going to worry about it for this case because I'm not really caring that much about how pretty it is. Next, I'm going to put our symbols in. So we put that legend in as well. So that tells us, hey, the colors that are assigned for our different clusters and then the symbols that we're using for the outcomes. Next, I can go ahead and put in our that might be, I don't know if that's a leftover one. What did I use that for? Oh, I'm sorry. That puts in the age score label at the bottom here. Basically, what we're saying is, okay, all of the x-axes are the age score. That's what we're trying to communicate there. And then the very last thing I want to put in is I just want to put the my computer variable on this bottom left corner. All right, and I want to put it in red. So now I'm just going to go ahead and render that on there. And there, hey, it's Arthur's computer. And voila, we've produced that plot. And this is one of the things that we're going to submit as part of our assignment. And then the ultimate idea here is we're looking at hey, how do these clustering assignments group up when we look at the various measures that we've produced here? And are there any patterns that we can pick out that would be worthy of further exploration? And so that's really what we're trying to do with these plots, is to give us an easy way to analyze the output of this clustering algorithm we've used. So okay, that's the part about using the fraud training set. Now we actually want to move into a larger data set, right? So here you can see that I'm actually going to read this CSV file. This is this fraud raw, which has I think 5,000 values into it. I'm just going to read it into this fraud variable. So now, boom, that's about all there is. I can clean this up over here. Looks like I made it angry at some point about something. So we've read fraud in. We can check out, geez, what did we create? We created a data frame. We can look at the column names that are in there. This is actually the data that hasn't been scored into what we have in our training set. So if we look at using the head command, it gives us the first 6 values. And here we have, oh man, we've got the actual values. These haven't been converted into that score between 0 and 1 for the claim and the age and the tickets and the prior claims and the attorney. We actually have to do that work. If we wanted to know a little bit about the data structure we got in here, it says, hey, we've got 5,000 rows, there's 7 variables, and it gives us a sense for some of the values that are in the various columns that came in. And so this is what you would typically do in kind of the real world, right? You'd read some data in, you'd start to explore it, and you'd begin to try and get a sense of what the shape of your data is so you can do further analysis. So there's other functions we can run against it. We could do a summary on it where it will go through and give you the min and the max, median, mean for all of your values. So that can be quite handy at times. You can do a summary on a particular column if you just want to see that, hey, the max age we have in there is 59, the minimum is 6, and then here's the the quartiles and the average for that. And then we can also run this quantile function, which will show you the assignments for the quartiles as well. And then we can also use this, just use the plot command without really putting anything into it other than just the age. And if we do that, we'll see that, hey, it just automatically creates a histogram of our ages here, right? So we can see the frequency out of these 5,000 values of the various ages of people represented by it, right? So there's a real quick way to just, barf out a histogram and see it's pretty evenly distributed. We can also use this table function where we can, you can see, just create a table. Here I've shown the gender and the age. So if you remember, 0 is female and 1 is male. And this shows us that same sort of distribution of the number of values across gender here. So, for instance, there's apparently 55 people in there that are 21 years old, both male and female. And then we can use this this range command. Tells us, what's the high and low values of our data as well. There's a number of different functions we can use to kind of explore our data set before we get into any of this clustering stuff, right? Because that's a big part of kind of data discovery and analysis, is being able to, you want to be getting in here and understanding the data as you try and look for things that might ultimately be useful from a descriptive or predictive perspective. So here, although I don't ask you guys to produce this, I've got an example of how you can create a line plot, right? So I've got, we're using our X and Y ranges, and we're going to produce a chart here. So I'll just go ahead and run this thing and show you what it produces. So that cranks out a line chart showing our age and gender here. So we can go ahead and add some titles and whatnot in here. So age by gender frequency, we can put a legend in that shows that the red line is female and the blue line is male. And if you say, hey, you know, why is this thing grouped up? We've just got some of those parameters kind of left over, so we've got a lot of space here, right, to render these things. So if I said, well, wait, I don't want to be rendering these in a grid. I'd like to look at this just all by itself right now. We can do that dev.off and execute that. That'll clean up our graphical parameters. And now if we were to render this thing, we should get a plot that occupies all of the available space down here for us. Okay, and so this just shows us the frequency distribution of you know, male and female across the various ages. Here we can, I just wanted to show you, hey, you can put different different plots in the same area, different types of plots. So I've got a bar and a box plot here. So if we just kind of execute this whole thing, now this shows us a, you know, the count of gender, male and female. I've colored these things pink and blue, and then this AB line function just gives you this capacity to draw a line somewhere that you want to. I just kind of arbitrarily picked 500 here. But you can see, you know, these are, you know, sort of histograms and box plots are used all the time in data analysis. This shows you your, you know, your min, the box plot shows you your min, max, you know, quartiles and your means, first and third, and your means across your data sets. So these are pretty frequently used. And if you look at this stuff, you'll see sort of how it is I set all these variables to draw these things exactly, you know, how I wanted to do it. If you're interested in this, then, you know, take these examples and then, you know, go from there. You can do just about, you know, if you can think of it, you can pretty much draw it inside of R. It's just a matter of, you know, suffering through it. So, all right, I got some other stuff I want to produce. I'm just going to, again, clean everything up. If I come down here, clean that up, and then we'll set some par up again, set our graphical parameters up again, and then we'll render these couple of graphs. And here, you know, just another set of histograms, just showing you different ways that you can just render these things, right? And the fact that you can put multiple plots on one space. Ultimately, the purpose of doing all this is you're going to want to be able to communicate this information to somebody and get them to make a decision on it, right? And so the visualizations are a very powerful function for doing just that. So there's a group of stuff in the middle there that is just sort of for your information. If you're really interested in digging into this, then it's good to get the basics of some of this stuff down and go from there. So, all right, now we actually want to run k-means on our larger data set. So again, we're looking at the columns that we have available to us. None of these has been transformed like our data set, so we actually have to write some functions to do that. And so I've gone through and actually created the functions inside of R to score people the way the textbook describes. So this does that age grouping score with this age categorization. This one does the claims categorization based on the logic that's in the textbook. And then for each one of the columns that we need to score using the function, this is the definition of those. So to get these functions, sort of read in so we can use them, just go like that, and that populates all those function definitions. And now we can actually use those to create new columns, right? So if we look at fraud right now, we've got, these 6 columns. I've probably been better off using the head command there. But what we're going to do is we're actually going to stick this age score in using the sapply, which will apply our calculation to every row down the age column using that age cat function that we just defined. So I'm going to go ahead and run that one. And if we were to look at head fraud at this point, we would see that we had added a column in. There's our age score. This is just putting the rest of our scores in. So I will just go run all of these. And then if we look at this head command one more time, you can see. And you might say, hey, Arthur, you've already got gender in there. Why did you put sex in, again, or gender in there again? Basically, because I wanted to get these columns that we're adding on in the same order as the columns we use to graph stuff above, so that we can easily just reuse all of that code we used on our training set, right? So I'm just cranking out another set of 6 columns that are in the exact same order, so that we can reuse all of those functions, which is why here I'm just going to recreate this outcome column, because that puts from age score on, gives us a set of 6 columns that's exactly in the same order as the set we had in our fraud training. And so now we've scored everything up. Here's our original data, age. Now it's been scored using our algorithm. We've got our claims scored using our algorithm, and our tickets and prior and attorney and all that. And I'm just showing the top 10 rows of that data set. All right. So now if I wanted to, I could actually write this back out to this fraud training CSV, right? So, hey, I've transformed this. I want to save this. If I wanted to write that out, I'd just, hey, write CSV, and it will write this out to my working directory with the file name that I gave it. And so now this fraud training CSV with these values that are in my data frame is written out to my local file system for future use or whatever else I want to do. All right, so we already inspected our data set. If we look at the 2 of these things side by side, you understand why I did what I did to our fraud set. Here, starting with age score, corresponds to here, and then we have our columns in the same order, which makes all the additional stuff we want to do work. So now you can see I'm creating the fraud cluster 10, but this time we're using our fraud data set, which has 5,000 members. We're using k-means, we're using columns 8 through 12. And so if you look in 1, 2, 3, 4, 5, 6, 7, 8, that's the age score right here. That's the column we're starting at, and then 12 takes us through our attorney score. And then we are saying sample 10 values to create your initial center and go from there. And we would like you to create 2 clusters out of this. All right, so let's crank this thing out. So we run this, oh, boom, it's done. So it doesn't take long to get through 5,000 values. And then if we take a look, there's our clustering assignments. And you can see here it says, hey, yeah, I didn't show you the other 4,000 of these I have. Here's the means that were created from our random sample. At this point, we wouldn't really have much of a sense of what those were, but we don't really care. There's the number of values that fell into our 2 clusters. So one of our clusters, was 2488, the other was 2512, which corresponds, almost roughly in half. And then, the rest of the stuff that that we saw before. So now, if we wanted to create a series of plots based off of this, I've just taken the exact same code that we used on our fraud training set and brought it down here to use all over again, right? So although variabilizing a lot of this stuff can be painful at first, if you reuse it, you begin to understand why you might want to do that kind of thing. Because now, instead of rewriting all this crap, I'm just going to reuse it. And lazy is the way to be when you're doing this kind of stuff. So here for X, we're just starting at the 8th position in our data frame. That's the difference between our fraud training sets. And then we're just iterating from there to render a number of plots. So, all right, let's clean up our mess. And now let's execute this thing for our 5,000 values, right? And now here is those renderings doing the sort of exact same thing. And all we're going to do is add our legends in just like we did before. And there we go. Got our clusters, our symbols, and you can see my computers is rendered there as well. Now, the one thing that we did a little bit different is we actually set this thing up so we can use multiple clusters. Whereas before we were labeling just sort of static label assignments, here we're actually using labels, selecting the unique number of outcomes that we came up with, right? And we also have in our function above, we're only using 2 symbols, but we've actually got this function that will crank out, you know, a number of symbols. So if we scroll all the way up to the top PCH symbol, you basically see that, oh, I didn't change this thing. Right now it just has the 17 and 18. It's the color that is set up to basically keep going, right? So if we have 10 assignments, the color will keep iterating a new color depending on the number of them. We only need 2 symbol assignments because we're just representing OK and fraud. So all right, I'm going to come way back down here to 3 to the end here again. And this time what I'm going to do is I just want to actually pick a different number of clusters. So one of the things clustering is, hey, what's the sort of right number of clusters? Well, I don't know. You know, we have 6 different variables, right? So 6 is sort of the maximum number of clusters, but it wouldn't be really all that useful because it just basically clusters our data on its individual attributes. Or we could have 1 cluster, but that's just 1 blob. We have 2 clusters, which might correspond with our sort of 2 outcomes, right? But maybe a different number of clusters would give us a better grouping and be more descriptive of our data. So if we wanted to change that, we can just come up here and rerun our fraud cluster. So here, say instead of 2 clusters, create 3. Rerun this thing. If we took a look at this, we'd see now that we have 3 cluster assignments. If we scroll up, we'll clean up our train wreck down here, and then we will rerun this whole mess. And now you can see that we have 3 different clusters represented in our visualization. And you know, whether or not this you know, is better or worse, I mean, that's kind of where the analysis comes in. The one thing I can say is, hey, this blue cluster here seems fairly tight, and the red cluster seems fairly tight as well, but then the green is just kind of all over the place, right? So, we could be getting closer, maybe not. So then again, if you just wanted to iterate through and create 4 clusters here, then all you would do is, reset this thing and then just run the whole mess all over again. And it should just re-render and give you the 4 cluster representation. Now we've got this light blue in the mix, and our labels are obviously adjusting here for the various cluster assignments. And so this is the kind of last part of your assignment, is to produce these various visualizations for an incrementing number of clusters. And hopefully this has given you a pretty good idea of how to do the k-mean stuff inside of a tool like R, and some of the options that you have for visualizing those results. There are additional ways to visualize cluster assignments. We're not really going to dig into it much more in this assignment, but I just want you to be aware that, hey, this isn't the only way to do it. I just want to get you comfortable with it, and then you can go out there and read about k-means visualization, and you will find a whole slew of information that will help you with that. One other thing you can do with this as well is you can render a data table here that shows you your distribution across these clusters as well. So yet another way to evaluate the data and the cluster assignments relative to the age score as well, right? So I just want you to work through this. I've given you all this code. I think it would be cruel to subject you to having to just learn this in an intro class. So what you're going to need to do is take this code and just manipulate it slightly to produce all this. I'd like you to work through all of this, use this to create assignment 5, and then hopefully this will help to cement your usage of RStudio a little bit and get you a little more comfortable with it, and get you used to working with data inside of R. So that's all I have for tonight. If anybody has any questions, please either speak up or feel free to chat me a question, or obviously you can reach out independently if you'd like to as well. So I will take silence as an indication that nobody has anything they want to ask right this second. But again, if you have any questions, please feel free to reach out to me, and I'll be happy to work through any problems you're having with this as well. Also, I'll do my best to get all caught up on the assignments you've submitted so far this week. I know a lot of you are probably kind of wondering where you're at with this stuff, but I'm pretty confident everybody should have done pretty well on the assignment so far, so I wouldn't be too concerned. We've got, this is our next big assignment, assignment 5, and then we've really got 3 more assignments to grind through before the end of the semester, and hopefully by the end of all that, you guys will feel like you are armed and dangerous for data analysis and data mining. All right, that's it for tonight. I will talk to you all next week. Bye now.